all, this is Madhumathi, Assistant Professor, Department of Food Technology, SNS College of Technology. So, in this topic, see something about the different methods of concentration, where one of the method is the membrane separation method. So, what do we mean by membrane separation and what for it is done? So, membrane separation is nothing but it is one type of technology which selectively separates the materials by the use of a semi-permeable membrane that will act as a barrier, and the separation will occur by the control through the membrane by the rate of movement of molecules between the two liquid phases, two gaseous phases, or a liquid and a gas phase. So in this picture we can see the gray color, the platform that serves as a membrane, and where it acts as a semi permeable barrier where the feed is fed from the left side corner of the membrane, and we get the retentate in the right side corner, and the permeate that is settling down in the membrane will be collected at the bottom of the membrane. So this membrane process, actually it is divided into the first generation membrane process and the second generation membrane process. So what are all the methods it comes under the first generation membrane is the microfiltration, ultrafiltration, nanofiltration, hyperfiltration, or otherwise we call it as the reverse osmosis, and electrodialysis. So the second generation is nothing but the gas separation, pervaporation, and the membrane distillation. So coming to this picture, when we see in this picture where they have discussed about the various types of membrane, that is the generation process, where based on the type of filtration method, that is either it is a microfiltration or ultrafiltration, or it is a nanofiltration and the reverse osmosis. So these four types of generation process is been these four types of membrane filtration has been discussed in this picture, where they have given how much pressure bar is needed for the particular membrane to separate the retentate from the feed. So here when we see the pore size, so here they have given the variation in the size of pore ranging from 10 to the power minus 1 to 10 to the power minus 3. So in this itself we can see that there is a greater variation when we give with the bacteria or the fat or the proteins or lactose, minerals and water that is passed through the membrane, where the reverse osmosis process only needs a much higher membrane pore size when compared to the microfiltration. So what type of materials can be used for this membrane process? So each and every different process of this membrane separation process needs different kinds of materials. So when we look into the microfiltration, the material used is polypropylene, and for gas separation and ultrafiltration they go for polysulfone, and again for gas separation and for reverse osmosis we can use polyamide, and ultrafiltration polyacrylonitrile is used, and microfiltration, ultrafiltration, and for reverse osmosis even cellulose is the best suited materials that can be used. And coming to electrodialysis, it is also one of the method where a semi-permeable barrier will allow passage either positively charged ions or the negatively charged ions, while excluding the passage of ions of the opposite charge. And these semi-permeable barriers are commonly known as the ion exchange or ion selective or electrodialysis membranes. So we can find the process of electrodialysis in the below mentioned picture. So next again is the gas separation. So what we knew by gas separation, as the word goes by, it is nothing but the separation of the gas mixtures. This process involves this above method only, and this separation is mainly how they get separated is due to their different solubility and diffusivity in the polymer membranes. And what will be the rate of permeation? So here the permeation will be proportional to pressure differential across the membrane, solubility of gas in the membrane, and diffusivity of gas through the membrane, and also inversely proportional to the membrane thickness. Here the driving force will be the concentration difference, and the best example of gas separation is the separation of CO2 from the natural gas. So next type in the first generation is the second generation is the pervaporation. So pervaporation is nothing but the separation of the miscible liquids. So here liquid is mainly maintained at atmospheric pressure on the feed side of the membrane, and the permeate is removed as the vapor because of the low vapor pressure that is existing on the permeate side, and differs from all other membrane process because of the here mainly what happens is phase change occurs in the permeate. And also here mainly membranes used are the zeolite and the polydimethyl cyclosine. And next is the membrane distillation. It is also one of the process in which either two liquid or solution but different temperatures are separated by using porous hydrophonic membrane. So here in this picture we can see the hydrophonic membrane that is used, and the hot feed goes in and the coolant will be fitted in on the other side, and a condenser foil also will be there. And in the next picture you can see how the two different liquid get separated in between the membrane. So here there will be a distillate channel, and the condenser will be acting upon this hydrophonic membrane to conduct the distillation process. And next is the flat sheet membrane, otherwise called as a plate and frame module. So this is like it will be having alternate ribbed plates and hollow spaces with membrane placed on either side of the plate, as well as a flow channel. So here these permeates will be connected from channels in support plates and leaves enriched in the most appropriate component. So this is the picture that represents the plate and the frame module, where the membrane is placed and the support plate and the permeate collector is been separated, and where the feed goes in, the blue color indicates the feed, and on the top we'll be getting the permeate and the retentate at the right corner. The main advantage is very easy to clean and replace the membranes if it is damaged or affected with corrosive content. Main disadvantage is actually low membrane area per volume. So this is the picture of the spiral wound configuration. So this spiral wound also sometimes where the spiral type of membranes is used, whereas in this picture we can see the right side in the color image we can see like that is the membrane is separated with the feed spacer, and where the permeate flow is actually shown in the picture, and they have a separate membrane envelope, and also like a permeate spacer, and a perforated permeate collection pipe is separate. How the spiral wound system works is mainly where it is being used is mainly for in the food industry, where the RO and the ultrafiltration is required. They go for use of spiral wound system membrane. So this is mainly like this model is wrapped like a spiral and placed in a cylinder shell. So main advantage is it is like turbulent flow is enhanced by spaces, and it has a high surface area. But disadvantage is low membrane as we told, and difficult to clean and sanitize, and also most expensive for high pressure because extra high pressure shells must be purchased. So this in this picture it indicates the tubular membrane. So in this tubular membrane also this also been used in certain fields like where we go in for a tube in shell heat exchanger. So there they go in for using the tubular module membranes. So here the feed solution is pumped into the tube through one end and forced in the radial direction through the porous pipes through the and the membrane. Relatively, this type is more easy and clean, and also can be replaced, and more expensive and high operating cost, and this also has a low membrane surface area, which acts as a disadvantage. So these are the hollow fibers that are shown in the picture. So hollow fibers are nothing but the members are in the shape of very small diameter hollow fibers. So here these fibers are closed at one of the tube bundles. Typically high pressure feed will enter the shell at one end and leaves at the other. So here the same thing, the permeate will they exit the device. So in this table it represents like different types of membrane module and the needed membrane area per unit volume, and what the membrane cost, control or fouling, and the application where it is being used. So this is about membrane concentration. Thank you.